Okay. So the first two, there's 3 proofs on the short answer tomorrow. The first 2 are from Unit 3. Okay? There's only 1 proof from Unit 3 on the short answer tomorrow. But these 2 look very similar to the one that's on there. So remember with the Unit 3, a lot of what we did was this stuff on your pink sheet. The parallel lines, alternate interior, corresponding, all that stuff. So this is kind of where you're going to look for Unit 3. So if I look at proof 1, what's always my first step? Given. So x is parallel to y, and angle 1 and angle 3 are congruent. Now on the short answer tomorrow, some of this will already be written in for you. I think we went ahead and wrote in the givens. Sorry about that. So you don't get the free points from the givens. Now, okay, so if you don't know where to go next, let's look at angle 2 and angle 3. What kind of angles are angles 2 and 3 in the picture? If you're looking at, like, this part. Alternate exterior. See how they're on the outside of lines X and Y, but on opposite sides of A? So we would write if parallel lines, then alternate exterior angles are congruent. Now, if you look at 1 and 2, you what kind of angles are angles 1 and 2? They're corresponding, but that's not what we're going to put next. Because look, we have 1 and 3, 2 and 3. Well, if 1 and 3 are congruent and 2 and 3 are congruent, can I cut out the 3 and make 1 and 2? What's it called when you cut something, the middle guy out? Transitive. Good. So transitive, POC. Now, the proof is that A is parallel to B. And that's because we said angle 1 and 2 are corresponding. So we're going to use the converse. If corresponding angles are congruent, then parallel lines. So if corresponding angles are congruent, then parallel lines. So the one that's on there tomorrow from Unit 3 basically looks exactly like this, but just with a different picture. If I give you one set of parallel lines, can you find the other? Yes. Yes. I'll give you the version. You know how I have the ones that we use in class that aren't written on? I'll give you one of those. Yes, you can use the pink sheet on the short answer, and I'm going to write these rules on the board for Unit 2. Okay? Other than that, we can't use any calculator. Okay, I'm not going to go through the second one because I want you to maybe try that on your own when we're done. It's very, very similar to one we did here, just a little longer. Okay, so flip to the back. Everything on the back is from Unit 4. Okay, everything on the back is from Unit 4. Either proving triangles are congruent, like this one, or going past it like the first two. There are 2 proofs tomorrow from Unit 4. One that stops at just prove the triangles are congruent, and one that goes a step further where you have to use the CP/CTC thing. How do you know the difference? Look at what you're trying to prove. Okay, and don't forget, these are just blank because I just got them from other quizzes and worksheets and stuff. The ones tomorrow there'll be parts in there. So I don't want to do all of them. Which one do you want? Which one looks the hardest? Well, let's start with this first one. 4. They're all hard, right? Okay, let's start with this one. We can do all 3. N and M congruent to PQ, and angle N congruent to angle P. That's all given. So remember, when you're doing this with the Unit 4, make sure you kind of mark up your diagram. So N and M, P and Q, angle N, angle P. So I have two things. What's my third thing that's congruent in this picture? You see the set of vertical angles with angle L? Angle L's congruent to angle L. If you wanted to be picky, you could say angle NLM congruent to angle PLQ. On the short answer tomorrow, I'll accept either one. If you want to give me 3 letters, give me 3 letters, or angle L was angle L. So my reasoning here is, if vertical angles, then angles are congruent. Now, see how our proof is not to prove the triangles are congruent? Now we can say triangle NLM congruent to triangle PLQ by which one of our methods? Which one of these guys? What do we think? Angle side. Do you see how the side's not touching the two angles? So this would be angle side congruence. Now we can say LM is congruent to LQ if the triangles are congruent, then all corresponding parts congruent. Okay, you get there? So, let's try the next one. We'll just keep going with these guys. So again, go ahead and put in your givens. YW perpendicular to XZ. That should be a perpendicular. And XY congruent to ZY. On the short answer tomorrow, none of the givens will be broken out. They'll just be right at the top. So, if you don't know where to go from there, remember, X, Y, and Z, Y are already congruent. I'm going to use the first part of the given to help me. Because what does perpendicular lines usually lead to? Right angles, right? If perpendicular, then right angles. So, which angle is the right angle? W, but you can't just say angle W. We got to be specific here. So we'd have to say like angle X, WY, and angle ZWY are right angles. If perpendicular, then right angles. Okay, you can't just say angle W and angle W are right angles. Be specific. So you got a right angle here, we got a right angle here. Now we have two options whenever we have right angles. We can either say if right angles and the angles are congruent, or we can say, I don't know where it is on the sheet, if right angles, then right triangles. But remember, we only want to say that if we're proving RHL. So let's skip step 3 for a second and go to step 4. What would be my last thing that I could say in this picture? What's something we haven't done yet? Reflexive, WY. So WY is congruent to WY. Reflexive. So the triangles are then congruent by which method? Do I have, what do I have here? Do I have the bad word? Do I have angle side side? So technically I have RHL. So because I'm doing RHL, I'm going to go back up here and say triangle XYW and triangle ZYW are right triangles. If right angles, then right triangles. if you were trying to, if this ended up being like side angle side, you would just want to say that the two right angles are congruent to each other. So if you're not proving, or like angle side angle, or if you're not proving RHL, step 3 is different. Step 3 is just that the two angles are congruent. You guys remember that picky thing? Is it coming back to you now that we've tried it a little bit? If not, I don't know what to tell you. Okay, last one. So I'm going to let you do the other one on your own. So the other thing that we used a lot in Unit 4 was midpoint. So I tried to give you everything that we did. We used vertical angles a lot. We used reflexive a lot. Right angles a lot. So now we're going to use midpoint. So B is the midpoint of AD, and CE. Sorry, you got to write kind of small. Should have given you more room. Here we're going past just proving the triangles are congruent. What does midpoint mean in terms of the next step? Yeah, like if B is the midpoint from A to D, AB is the same distance from BD, right? And then BE would be the same from BC. So we're going to write both of those in step 2. AB congruent to DB and BE congruent to CB. If I want you to write 2 things in one step tomorrow, I will put 2 lines so that you know I want 2 things in that step. And that's the midpoint one. Remember the midpoint one? If midpoint, then segment divided into 2 congruent segments. So if midpoint, then segment divided into 2 congruent segments. Now, what's the only thing I have left in this picture? I got another pair of vertical angles, angle B. So angle B congruent to angle B. If vertical angles, then angles are congruent. Now the 2 triangles are congruent. Triangle ABE congruent to triangle DBC. By which method? Everybody see side angle side? Side angle side congruence. So then AE is congruent to DC if the triangles are congruent, then all corresponding parts congruent.